All right, so we just got done looking at interpolation, and interpolation is using the equation of the regression line to make predictions for your response variable. And specifically, you're choosing x values that are in and amongst the points that are already on your scatter plot. So if you chose an x value that was way away from the points in your scatter plot and you tried to make a prediction, that's known as extrapolation. Okay, so the formal definition of extrapolation is that extrapolation happens when we use a regression line to find a value outside the range of values of the explanatory variable x. So for example, if I had a data set and the x values for all the points were between 10 and 20, and I chose x equals 75 and plugged that into the equation to make a prediction, that would be extrapolation. So extrapolation is also a faulty way of logic. So this is a fun example from when I was a teenager. A politician was asked, if the speed limit is 60 miles per hour and everybody drives 65, why don't you just change the speed limit to 65 to match what people are driving? I thought that was a really good question. As a teenager, I was like, yeah, why don't we do that? So the politician's response is really interesting. He said if the speed limit was 60 miles an hour and everyone drives 65, so he changes it to 65, then everybody will drive 70 miles an hour. And so we'll ask him to change it to 70, and then everybody will drive 75. And then we'll want him to change it again, so he changes it to 75, and now everyone drives 80. And the next thing you know, everyone's driving crazy fast out of control. And I was like, okay, yes, but there's some limitations there. So for example, at the time I drove a really old car, and I don't think that it would have made it past 80 miles an hour. It probably would have rattled itself apart. Right? So, there's a limitation on the car, whether that's 80 miles, 100 miles an hour, 120 miles an hour. Maybe some race cars or expensive cars will get up to about 200, but there is a point at which the car just physically cannot go any faster than that. There's also a limitation with the driver themselves. So I lived in Montana for a while, and the speed limit on some of the highways is 90 miles an hour. And while I did appreciate that I got somewhere faster, I paid such close attention to the road because it felt so fast to me. And I was just terrified of being in an accident or, I don't know. But I would not have been comfortable driving much faster than that just out and about on the highway. So there's also a human factor there that limits how fast someone's going to drive. So while his answer is probably true in the short run, the politician is not correct. People are not going to endlessly go faster and faster until they reach infinity and beyond. Okay. All right. So now that we've kind of given a little background to what extrapolation is, let's go back and revisit the example with the ice cream. So if we look at the points on the ice cream graph, they go from about 12 degrees Celsius to about 25 degrees Celsius, looks like about the furthest point out. So if I wanted to try and make a prediction using 29 degrees, that's 4 degrees more than the last point. So that's still sort of close, and maybe that prediction might be okay. If I tried to use this for some point that's much further out, that would absolutely be extrapolation. Sometimes though, these ones that are really close to where the end of your data points are might be okay, they might not be okay. With this one, 29 degrees gave me a predicted sales of $740. 29 degrees Celsius, though, is about 85 degrees Fahrenheit for those of you in the US. And I used to run a big city park that had a snack shack, and we sold ice cream there. And what I found by tracking the data is that the park was the busiest when it was between 76 and 79 degrees. If that was the forecast for the weekend with sunshine, we were going to be slammed. But if it got up to like 85 degrees, the park would be almost dead because it's just too hot and it wasn't enjoyable for people to be there. So when we hit 85 degrees, my sales were just totally down the drain. So depending on the situation with this ice cream shop, that could be a valid prediction, or it could be extrapolation like it would be if I was trying to use this model at the park that I ran. All right, so we're going to revisit the airfare cost and the push-ups and video games example. So I'd like for you to go ahead and pause the video, and you have a couple of questions on your notes with extrapolation relating to this. So go ahead and give those a try. All right, so hopefully you gave this a good try. Let's look at the first one. The first one, we're going back to the airfare one. So they wanted us to predict the cost for a flight of 2,842 miles. So I plugged 2,842 miles in, and I get that the cost should be roughly $415.78. The question is that extrapolation? This would definitely be extrapolation unless we had a lot more information about the pricing of airlines, but simply based on the data points that we collected, this is way too far away. So the furthest point that we have out in terms of X values is about 1,500. They're asking us to make a prediction for 2,800. So that's more than 1,300 miles further from the greatest point in our data set. So that would definitely fall under that category of extrapolation. And then the push-ups and the video games. So this one didn't ask you to make a prediction. It asked you what would be reasonable values to use with this equation. So we don't have any data points to look at to guide us. That's a great way if we had those. So we're stuck with kind of some of the practical limitations of this. So let's start. The first practical limitation that I can think of is that there are 24 hours in a day. So the smallest value X could possibly be is 0. And the largest value is 24. So 0 to 24 hours. Okay, that would be one limitation. Another limitation would be that you can't do a negative number of push-ups. So if any of those values between 0 and 24 gave us a negative value, that's also not going to work. So I went ahead and plotted the equation of the line for the values of x equals 0 to x equals 24. And what we can see is that the smallest number of push-ups predicted by that is 7.2. And the greatest number of push-ups predicted by that is about 38.5. So all of those values are positive values for the number of push-ups someone could do, so that's great. This means that the range that would work here would be 0 to 24. You might have said 0 to 16 because you're thinking people get 8 hours of sleep, but that would be fine too. I mean, that would be another restriction as you do have to kind of factor in that sleep and things like that. All right, so hopefully that gives you a little bit better sense of kind of things to think about in terms of when extrapolation is going to occur and some of those values that you can plug in to make predictions.